Blockchain offers three key opportunity areas to be leveraged and add value to the IoT. First, providing stakeholders in a given ecosystem the access to data stored on a blockchain builds trust through transparency. A tamper-proof record of device interactions and transactions establishes a single source of truth in which a stakeholder ecosystem can rely on. Trust is further established using blockchain by removing centralized authorities and intermediaries from certain activities and processes that are prone to fraud, corruption, or cyber hacks. Second, secure interoperability can be achieved using this technology, which is critical for safely realizing the benefits of the future of IoT. Lastly, the progression of IoT is moving toward a world with autonomous devices and systems, such as self-driving cars, drones, or robots, which must be governed in a way that can be trusted. Now, let's move forward and talk about each of these areas in more detail. The current trust model is based on central authorities and trusted intermediaries. Banks, Google, Facebook, and AWS all serve as trusted parties holding customer funds or personal data. A blockchain is a secure, tamper-proof record of data. Each link added to a blockchain is secure and unalterable. The ledger is maintained by a distributed network of nodes which individually contain a copy of the ledger. Once a block has been approved by network consensus, data in previous blocks cannot be changed, added, or moved without the need for a central authority to manage this data. Truth cannot be corrupted on a blockchain. This feature is important for IoT in a few ways. A key feature and benefit of blockchain is the ability to establish and share a single source of truth with multiple stakeholders with a need for the data. More specifically, blockchain for IoT can register, certify, and track products shipped between multiple parties through a supply chain with transactions time-stamped and verified in a secure encrypted environment. Suppliers, manufacturers, distributors, retailers, customers, and even regulators can access blockchain data that no longer has to be reconciled months later, but available now in real time. For example, Walmart recently announced a blockchain project to track the flow of lettuce through its expansive supply chain. This is in response to an outbreak of contaminated lettuce which sickened dozens across the U.S. Walmart, in conjunction with IBM, piloted a distributed ledger which tracks each bag of spinach and head of lettuce. According to Walmart, the blockchain-based system can pinpoint the exact location of a contaminated product with better accuracy, as well as identify the potential source of the contamination. In this case, the ledger is the source of truth for the tracking of lettuce. One of the most exciting capabilities of the blockchain is the ability to maintain a truly decentralized, trusted ledger of all transactions occurring in a network. This capability is essential to enable the many compliances and regulatory requirements of industrial IoT applications without the need to rely on a centralized model. Compliance with regulations involves back-office processes and systems that are onerous and often inefficient. There's an inherent latency in the compliance data that first must be collected, reconciled, and then reported to regulatory bodies. In the Walmart example, sensor or device data may be reported to regulatory bodies to ensure compliance with food safety or organic certifications. Transparency is a key attribute and component of trust, but blockchain cannot solve all issues of trust. For instance, products can still be tampered with and counterfeited. However, blockchain technology brings a new form of trust and transparency to at least begin to combat some of these issues. In an ideal state, all IoT devices should be able to interoperate and share information between each other. In order for this to be realized, standard communication protocols must be in place. Blockchain offers a potential solution here by leveraging its peer-to-peer messaging capability. For instance, the IoT can use blockchain to enable secure, trustless information exchanges between devices across a given network or verticals. This approach is similar to how the Bitcoin network handles financial transactions. Moreover, smart contracts can be utilized to codify, execute, and enforce contractual terms or agreements between devices. Blockchain may have promise as a foundational element for bringing autonomy to IoT systems. Blockchain brings the potential for autonomous connections between IoT devices without the need for a central authority. Having a tamper-proof record of all smart device history that is maintained by a distributed set of nodes that approves any updates to the ledger through consensus opens the door to many IoT applications that have been either aspirational or simply impossible without blockchain. For instance, 2 autonomous vehicles are commuting into the city to pick up Alice and Bob from work. Alice's car is in traffic directly behind Bob's car on Highway 5. Alice has an appointment on her calendar after work and is in a hurry. Bob's schedule after work is free, and he's headed straight home. Alice is a CEO and has a time optimization solution that maximizes her time in a given day by minimizing time spent commuting in traffic. Based on Alice's needs, her autonomous vehicle optimizes its route based on her calendar and traffic conditions. Autonomously, her car communicates with Bob's car and requests to pass. In exchange for this kind gesture, Alice's car transfers a digital currency to Bob's car. To execute this scenario, the blockchain is utilized as a shared ledger of all devices and stores the history of all device interactions and transactions. In this brief example, 2 cars of different make can discover each other, communicate, and transfer economic value in a trusted manner, leveraging blockchain technology.